guys. Another wonderful edition of Patio Productions where we do pre-calculus from Mrs. Fox's patio. Today we are going to start section 16-3. So because we have kind of like a little bit of time on our hands, and I really wanted to make sure that we really get section 3 down really well. I decided to split it up into 4 days. Seriously, 4 different days we're going to be doing this section. So we're just going to do it in little bite-sized pieces, and the homework is in little bite-sized pieces. I think that the hardest part of this particular section is the algebra. Yeah, so we're going to really want to practice our algebra when we do our activities during our class time. We're definitely going to be spending a lot of time with the algebra. And so depending on when you're watching this, if you watch it after we do the activity or before, just know that there's lots of practice that is coming your way to help you out. So let's go ahead and get started here. So I am going to be presenting our lovely PowerPoint that we have going on. And for our PowerPoint for today, again, we're going to do section 3, and this will be day 1, okay? So just day 1 of this guy right here. That's all. And the first thing we want to do is actually, we're not going to take notes just for like the first slide. I want to show you a little bit of some theory. Yeah, like how this is going to come about. But the title might be interesting to you. Okay, this says tangent to a curve. Okay, so what a tangent line is, if you go back to like geometry class, like way back in the day, there was some vocabulary that we learned about circles, like a secant and a tangent. And I want to start with that geometry concept first. Take ourselves to a Desmos graph and then talk about like how what we've been learning in the last couple of sections correlates to what we're going to learn right now. And I'm so excited for you guys. This is going to be awesome. Okay, so don't write the entirety of this first slide. It's just exploration time and looking at a Desmos graph. Okay, so if I asked you to find the slope of a curve, that might make you think like this. Mrs. Fox, I don't even know if that makes sense. How do you find the slope of something that's curvy? And the only thing I've done slope for is with lines, okay? Well, like, does this even make sense to us? So hopefully you're saying to yourself, this kind of doesn't make sense. This is a little bit weird. Like I'm confused on how this could be. And so basically what's going to happen is we have to introduce a calculus concept. I know, it's kind of cool, okay, to figure this out, okay? So we're going to introduce a calculus idea and as we are delving into like these pre-topics, and that's why this chapter is so important for you guys to learn, okay? It actually utilizes limits. Oh, that's why we've been practicing limits so much. Yes. Okay. We're going to be practicing. That's why we've been learning limits so much, is because we are going to try to combine this idea of a limit with a little bit of something from geometry class. Okay. So a secant was a line that intersected a circle at 2 points. So if you had a circle, right, you had a circle, it's the line and it intersects the circle at 2 points, right? I don't know if you can see that or not. Okay. A tangent, however, okay, was when we had a circle, but then it just intersected it at 1 point. Okay. And so what's going to happen is we're going to take something that's the secant and we're going to try to turn something that's a secant into something that's a tangent. Okay. And instead of it being in specifically a circle, it's going to be for, quote, any kind of a curve. I know, so fun. So we're going to go to Desmos just to check this out. So I'm going to show you a little Desmos graph, okay? Just a little Desmos graph that's going to help us figure this out. So what's going to happen is, if you can see, do you guys see, like this part over here actually doesn't even matter that much. I'm just going to actually get rid of it and just really focus on this curve right here. Okay. So do you guys see that we have like this curve? It has a certain graph to it, whatever, it doesn't even matter. And then there's this red line that is definitely like hitting this curve in 2 different spots. Okay. So what's going to happen is we're going to try to make this secant line turn into a tangent line, right? So this right here is definitely hitting the curve twice. We want to see if we can get that curve to now hit the curve just at 1 time. Okay. And so I can do that by sort of like moving these 2 points closer together. If I take this point and I start dragging it, okay, towards, like along the curve, what do you notice is happening about this curve? Okay, so let me go put it back. So what you're noticing is that this curve, this point is getting closer and closer to the other point. Do you notice that the secant line is becoming like steeper and steeper and steeper? And then look at it now. Oh wow. It's almost like it's like touching it twice, but then I get even closer. Oh my goodness. It's like almost going to touch it. Bing, 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 bing. One time. Ladies and gentlemen, we have now moved this point. So now they're right on top of each other. Can you guys see that? Right? And now this secant line has become a tangent line. So what has happened, guys? What we're going to do is we are going to examine the slope of this red line. And we're just going to do like old school slope, like, y2 minus y1 over x2 minus x1, except we're going to do it with function notation, of course. And it's going to say like f of x sub 2, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. But then we're going to make the limit of that secant line, we're going to make the limit as those values get closer together. So we're going to take this distance between them and start making them go towards each other. And then what we are going to do is we're going to combine a slope formula with a limit formula, and boom, just like that, we're going to get how you can find the slope of a curve. I'm so excited for you guys, okay? So what I want us to do is I want us now to draw this a little bit for ourselves. So now I want you, we're going to write just like a baby version of what I just did on Desmos. So now your pencil's up, you're ready to rock, you're taking some notes, okay? And it says, so we want to make a secant line become a tangent line, okay? A secant line, we want it to become a tangent line. So I just drew like a random curve on this, like a random curve, okay? So here is just a curve. This is point P and point Q. Point P is at x equals C. Point Q is just at a random other x. C is going to be sometimes a particular number, and that's what we're going to practice today, making C be a particular number, and then sometimes C is just C. Okay, we are going to illustrate a tangent line. So we have this tangent line right here. So what's going to happen is let's figure out what the slope of that segment PQ or the line PQ is. So like old school slope. Okay, the slope is going to be, okay, we got to do our coordinates. So if I fill in the coordinates, let me get my little pencil going here. Where's my pencil? There he is. Okay, this coordinate right here is at C comma f of C, because this is the curve of f of x curve. Okay, so this is our f of x curve. And then this coordinate, because the x guy is just x, this coordinate is x comma f of x. Let's do the slope for this guy, okay? The slope for this guy is going to be f of x minus f of c, which is like y2 minus y1, right? We're just doing the y values, okay? So f of x minus f of c all over x minus c, which is like x sub 2 minus x sub 1. Okay. Well, what we want is we want this Q value to get closer to P. We just saw that happen on the Desmos graph. Remember how pretty that was? I know, it was nice, right? And so what's going to happen is we're going to make that Q get closer to P. To make Q get closer to P, what's going to happen is that X is going to need to get closer to C. So in an effort to make Q run into P, we need this X value to get itself closer to the C value, okay? And so if X is getting closer to the C value, there's a mathematical way to say that we've been doing a lot of, and that is the limit, okay? So we're going to now take this slope of the equation right here, and we're going to put a limit in front of it. So it's going to be the limit as x approaches c of f of x minus f of c all over x minus c. Ladies and gentlemen, this is a version of the difference quotient. Woo! I'm so excited, okay? We had another version of the difference quotient that we practiced a lot too, where there was like an H on the bottom. This is another version of the difference quotient. I can't even wait to do all the fun mathematics with it. Oh, I'm so excited, you guys. Like, it just makes me want to go like, yes, our mathematical powers, yes, okay? So this is a version of the difference quotient. Now, this represents the slope of a tangent, okay? So this is, if you want to put like an M equals for me, okay, this is the slope of the tangent line. We are going to do a whopping 2 examples. Yes, just 2 examples, because the concept is not really that difficult. It's probably just the algebra that weighs us down a little bit. Like, I know, it's just the algebra skills that fail us sometimes. So we're going to do 2 examples, and one of them is going to have to do with a square root and how do you deal with that, and one of them has to do with a quadratic. So just 2 examples on how we can deal with finding the slope of a tangent. Okay, so this is example number 1. It says find the slope of the line tangent to a curve, f of x equals rad, the square root of x plus 4, at the coordinate p is 5, 3. Now, is 5, 3 really on this guy? And you could plug it in and decide yes. If you plugged in 5 for x, 5 plus 4 would be 9, and the square root of 9 is 3. So this totally checks out, okay? So what we're going to do is we're going to do the formula, okay? So here, we're going to draw a sketch first, like duh. Of course we are, okay? Sometimes it's nice to just have a picture of how this looks, okay? So this is in fact a square root graph. We know in general that our rad graphs start at 0, 0, and it looks like half of a sideways parabola. It looks like this. Okay, this guy, because it says x plus 4, has been moved 4 to the left, thinking about our parent function, okay? So we have this beautiful graph that looks like this. So it's a rad function. It's moved 4 to the left. I just draw this cute little guy. I'm sure he looks lovely. Yay, us. Okay, the coordinate 5, 3 looks like it would be about right there. Sounds good. Looks beautiful. And now what we're going to do is we're going to try to find the slope of the tangent line. So we're looking for a line that's like kind of like this, right? Okay, that's kind of wobbly, but that kind of a line right there, we're going to look for the slope of that line. So when you see this slope, you can kind of like in your mind feel like that looks kind of like a very shallow type slope, right? So I'm thinking like 1 would be right here. If I make my arm be a 1, it looks shallower than a 1. It's positive for sure, but maybe it's going to be like a fraction, right? Like a 1/2 or a 1/3. So I kind of like have this weird kind of like vague idea of like what I want it to be. Let's see what happens when we do the mathematics and if that makes sense to us, okay? We're going to pick any other point on the graph. It does not even matter what it is, just x comma f of x, and then we'll make our secant line that is going to then turn into our tangent line. Let's get the formula down. The formula for the slope is that the slope is equal to f of x, the limit, you always have to start with the limit, of course, Mrs. Fox. The limit always goes first. So the limit as x approaches our target value. So this is our target value right here, okay? Our target value is in fact a 5. So we're going to put the limit as x approaches 5 of f of x minus f of 5 all over x minus 5. If you were to plug in 5 right now to this equation, f of 5 minus f of 5 over 5 minus 5, you would get 0 over 0, which does not make any sense at all. So that is not what we're going to do. We're going to have to do some algebra, and we're going to try to sort of like make some of this stuff go away and simplify it up, and then we'll get a beautiful answer. So let's go ahead and fill some stuff in. So what is f of x? Okay, well, f of x is the equation right here of x squared plus 4. What's f of 5? F of 5 means the y value when you plug in 5. And of course, we already identified that that was 3 right here, okay? And then, so that's what I'm going to do. I'm going to say the limit as x approaches 5 of rad x plus 4 and then minus 3 and then over x minus 5. Again, if I plug in 5, it's going to be 0 over 0, which is not cool. So how am I going to work with this? Well, this is why we have to practice the algebra, okay? This algebra right here, probably the only way we're going to make this work is we've heard back in the day, remember like back, you can like rationalize denominators, or this time we're going to rationalize the numerator because we want to get a way to like simplify this and like figure out a way to get some different numbers in here. So what I'm actually going to do on this one, okay, is we are going to multiply the top and the bottom by the conjugate of the top. I know, amazing. We're going to multiply the top and the bottom by rad x plus 4 plus 3, top and bottom. Now, on the bottom, I'm going to be honest with you, folks. I'm going to keep this guy in parentheses. I'm going to keep this guy in parentheses, and I am not going to distribute that. That would just be a hot mess. Nobody wants to do that, okay? Like, seriously, we don't want to do that, okay? Like, whoosh, catastrophe, disaster. But what I do want to expand is this top, okay? We technically have a binomial times a binomial. So when you do it and a rad x plus 4 times a rad x plus 4, that just becomes rad x plus 4 squared, which just becomes x plus 4. Okay. When I do the rad x plus 4 times the 3, and then this negative 3 times the rad x plus 4, I get the positive version and a negative version. So those are going to cancel. And then the last thing I want to do is this negative 3 times the positive 3, and I get a negative 9. Okay. So again, I'm going to just multiply the top part. So I feel like I'm showing my work just a little bit here. I'm going to multiply the top part, and then on the bottom, I'm not going to multiply this out. That would be silly. Guys, basically what's going to happen, like secret, like let me just let you in on the secret here. Like, here we go. Okay, we're trying to make this x minus 5 cancel. And so by sort of leaving it here, it's going to be like able to like ready and cancel itself. So on the top part, okay, can I let you guys in on a secret? Do you notice how Mrs. Fox is starting each of these guys with the limit as x approaches 5? Guys, that's the beginning of the sentence, okay? Every sentence needs a beginning. Otherwise, you have no idea what I'm talking about, right? If I said, won an award, you'd be like, who won an award? What won an award? What are you talking about? I need to know. What are you talking about? Oh, you know what Mrs. Fox did? She's so silly. She left off the beginning of the sentence. Okay? So you can't leave off the beginning of the sentence, folks. The beginning of the sentence is the limit as x approaches 5. So I wrote the limit as x approaches 5 of just x plus 4 minus 9 over x minus 5 times the rad x plus 4 plus 3. And then you can kind of see what's going to happen. Do you see it? Do you see it? Do you see it? Okay, we are going to simplify this numerator, and it is going to become an x minus 5. Yes, this is so exciting. We're going to take the limit as x approaches 5 of x minus 5 over x minus 5 times rad x plus 4 plus 3. And then in true algebraic beautiful fashion, folks, these x minus 5s do get to cancel. All I'm left with is the limit as x approaches 5 of 1 over rad x plus 4 plus 3. All of this mathematics that I did from here all the way to here was trying to get this into a place where I could finally plug in 5, and then the algebra works. And now, boom, just like this, I am ready to rock. Okay, if I plug in 5 now, I'm going to have 1 over the square root of 5 plus 4, which would be 9. So the square root of 9 plus 3, the square root of 9 is 3, okay? 3 plus 3 on the bottom is 1/6. Folks, the slope of this tangent line that I tried to draw it right here very sloppily, okay, its slope is 1/6. Do you believe that? Do you believe that this line right here, if it was a tangent line, do you feel like that line right there would have a slope of 1/6? I actually could believe that. My picture looks pretty accurate for that. So just like that, guys, you have found the slope of the tangent line at a particular curve. I think that was some pretty good work. And so the algebra, again, if somebody were to just see this, like just right now, walk in the room, they would be like this. Whoa. Okay. Now you might even be like this. Oh, that looks difficult, but it wasn't difficult. It's a process. Okay. You do the process, you fix the algebra, and it all works so beautifully. Let's do another example. Okay. So this one says find the slope of the line tangent to the curve. And here's a new curve that we have. It says f of x is x squared minus 5x plus 8. And then the coordinate is going to be at 1, 4. Okay. Is 1, 4 really on this parabola? Well, let's just do it really fast in our heads. 1 squared would be 1 minus 5 times 1 is 5. And then we would add 8. And does that in fact give us 4? Yep. Yes, it does. Okay. So this coordinate is totally on the picture of this parabola. Okay. So let's get right to it. I'm actually going to draw the picture at the end this next time, just so we can confirm with the picture. And you're going to be like, oh my goodness, that makes total sense. And it's going to be amazing. Okay. So here's the definition of how you find the slope of a tangent line. Sorry, that was sloppy and I just ran into all the words. You're going to say the slope is the limit as x approaches 1. Why is it 1? Because that's the x coordinate of my point. The limit as x approaches 1 of f of x minus f of 1, because that's our c value, over x minus 1. Okay, let's fill in some stuff. Okay, f of x is the equation. Again, we start by writing the limit as x approaches 1. The equation for f of x is right here in the question. X squared minus 5x plus 8. Then I'm going to subtract the y value, right? The y coordinate is a 4. And then I put over x minus 1. Beautiful. Folks, if you plugged in 1 right now, do you know what would happen? You would get 0 over 0. That means nothing. So again, we have to do some algebra. We have to exercise our algebra skills, right? Our strong algebra skills. And let's get it. So maybe like this x minus 1 on the bottom can cancel. And then we're able to toss in a number. Okay, so let's go ahead and do this. So I think I will just sort of like combine these top things. I don't even have to do any fancy algebra. I just need to put together the constants of this positive 8 and negative 4. And so I get as x approaches 1 of x squared minus 5x plus 4 now, all over x minus 1. Anybody want to guess that maybe this guy's going to factor into something? Anybody want to take a guess? Anyone in the backyard? Foxy back there? No, Foxy's really quiet today. I don't really know. But ladies and gents, I'm going to guess that one of the factors of this x squared minus 5x plus 4 is going to be x minus 1. Let's see if that's true. Oh my goodness, it's true. It's true. Okay, x squared minus 5x plus 4 totally factors to be x minus 1 times x minus 4. And then we have over our x minus 1. Oh my goodness, I have chills. I'm so excited. The x minus 1s are going to cancel. All I have left now is the limit as x approaches 1 of x minus 4. I can plug in 1 now, can't I? And I get a lovely and beautiful answer of -3. Ladies and gentlemen, apparently on this parabola at the point 1 comma 4, the slope of the tangent line is -3. Let's bring up a picture and see if we can prove it to ourselves, and let's see if that makes sense. Okay, I went ahead and graphed this on Desmos, and I just pulled up the graph real fast. This is the equation of the parabola. This is the coordinate 1 comma 4. Okay, this would be the tangent line, folks. Does it look like that this tangent line has in fact a slope of -3? By golly, guys, I actually think it does. Check it out. You're going to go down 1, 2, 3, and over 1. Oh my word. It's gorgeous. It's beautiful. It all makes sense. Okay, ladies and gentlemen, for your homework. Now, remember, we're doing bite-sized chunks, okay, just bits and pieces. You're going to be doing page 869. You're going to do numbers 1 through 10. Every single question of 1 through 10 says find the slope of the curve, okay? Oh, excuse me, the slope of the tangent line. Mrs. Box said the wrong thing. She was getting ahead of herself, okay? You're going to find the slope of the tangent line. You are basically going to do, right, you're just going to do this equation with the appropriate number every single time, right? Whatever the x value of the point is, you're going to fill those babies in, and you're going to go ahead and find the slopes, okay? You don't have to graph them. The graphs that I did were for you to believe it, to prove it to yourself. So you do not have to graph them yourself. However, if you're feeling jazzy and you're like, ooh, I'm going to pull up Desmos and I'm going to see if that actually works, please do so, guys. You know I'm a big fan of Desmos. I would highly encourage that, okay? All right. Ladies and gentlemen, that is our lesson for today, okay? So I hope that was a great introduction. We got to see a Desmos graph and the theory behind it, which I think is so amazing and so cool. We practiced some algebra. Again, we will do more practice algebra when we do our in-class time. And yeah, I think it's just really about doing the algebra and just keeping everything organized. And I think that's it. Okay, guys, I hope you're having a wonderful day. I'm going to exit out with our fanfare music. Have a good one. Bye. See ya.